We welcome everyone to this webinar from the G3-PLC Alliance about regulatory regime and G3-PLC deployments in FCC band in Europe. We're glad so many of you are joining today in this webinar, so it seems a topic which is interesting for many people. I noticed from the list of participants that most of the attendees are familiar with G3-PLC. Not all of them, but most of them are. So I will only say a few words about G3-PLC before coming to the actual topic of the webinar today. So as a short introduction, this one slide about G3-PLC. G3-PLC is a proven power line communication technology offering lowest total cost of ownership and independency on telco operators. It's a cost-effective communication solution, as utilities, as you know, use their own infrastructure for communication. It provides very robust communication under harsh conditions. G3-PLC is an open international standard, so freely available to anybody who wants to use it, and it supports end-to-end IPv6 connectivity. And originally designed for smart metering, that's still the main application for G3-PLC. But as you can see on the right side of this slide, it's also used in a growing number of other applications, such as street lighting, grid control, home automation, and even in smart railway applications. It's a mature technology. It's being used in over 30 countries, in more than 80 million devices in the field. So it's widely used all over the world, from France, of course, to South Africa, and from Japan to Colombia, really globally being used. And also important, G3-PLC is backed by an international group of nearly 100 DSOs and industrial players, all supporting the continuous development and use of G3-PLC globally. So that's my brief introduction about G3-PLC, and then we come to the topic for today, which is using FCC band plan in Europe. Most G3-PLC implementations in Europe use, of course, the Senelec A band, but practically all implementations outside Europe are in the FCC band. And regularly we get questions from DSOs, from manufacturers, about using the FCC band in Europe, as there is the belief that the FCC band is not allowed for smart metering in Europe. But the examples on this slide about implementations using FCC band in Europe clearly show that is a misunderstanding. For example, most utilities in Austria use G3-PLC, and also most of them use the FCC band. For example, Netz Niederösterreich is working in the FCC band, and Wolfgang Lehner from Netz Niederösterreich will go into details about that. The rollout in Luxembourg with Creos is completed, but was also done almost completely in FCC band. And in Latvia, the DSO ST is in an ongoing rollout of G3-PLC meters, and they're also using the FCC band plan. So just to give a few examples, we know there are more implementations using the FCC band in Europe. And to clarify about using FCC band in Europe, we organized this webinar, and we want to answer the following 4 questions on this slide. So first of all, what are the benefits of using FCC band? what are the EMC aspects in Europe? How do you get the CE marking regarding EMC specifically in the FCC band? And how can utilities use the FCC band for smart metering rollouts in Europe? And the last question will be addressed by Wolfgang Lehner from the DSO in Austria. So that's the agenda for the coming hour in this webinar. We will address each of these 4 questions. To answer these questions, we are joined today by 3 real experts, not only about G3-PLC, but especially about regulatory aspects and using the FCC band. So I very much appreciate and want to welcome Cédric Lavenu from EDF R&D, Anil Mengi from Develo, Germany, and Wolfgang Lehner, as I said, from Netz Niederösterreich. Each of them will make a short introduction before they start their talk, answering the different questions. So thank you for joining and presenting today in this webinar. And then let's start with the first question, the benefits about using FCC band. Cédric, can I hand to you?
Thank you, Leon. Good afternoon, everybody. So, of course, I'm technical lead of the workshop 1, which is the technical working group of the G3-PLC Alliance, and I'm also trying here to answer these questions about the FCC band, also having my experience in standardization in Senelec, as I'm also chairing a Senelec committee, T219, it's a committee for mains communication systems. So as you will see, the standards being developed in what we call the Senelec bands is also one main focus of my job. So that's why I'm also trying to give some answers here. So if you go to the next slide, Leon, I'd like to remind that G3-PLC has been designed to operate in several band plans to match different use cases. So when you look at the general spectrum, what we are actually really focusing on is the narrowband PLC frequency range up to 500 kilohertz. Below 3 kilohertz, we'll have ripple control applications. Above 500 kilohertz, we'll have the broadband PLC frequency range. Have a lot of BPL devices that are typically installed inside homes, for example, for multimedia, but many other application use cases, also in the smart grid sometimes. But here, G3-PLC is a narrowband PLC technology, of course, and it basically offers band plans in the whole range from 3 to 500 kilohertz with the Senelec A band plan, the Senelec B band plan, array but FCC band plans as well, right? So if we go to the next slide, you can see so these band plans are there to match different needs and also to match different regional regulations. I'll be careful with the word regulation the first time. I'll try to explain a bit more about regulation standards in the second part of my presentation. But when we look at this whole frequency band, we see that there are 3 main regulatory areas in the world, or at least 3 main regulations that exist that can be taken over by different countries which do not basically apply this regulation by default. For example, the FCC regulations sometimes used in other parts of the world, which are not necessarily the US, which are taken over by other national bodies, for example. But what we can say is that we have typically the ARIB regulation, which is the Japanese one, Association of Radio Industry and Businesses, the FCC regulation, which is set up by the Federal Communications Commission. And then we have the European regulation, which when possible is based on harmonized standards, which are developed by Senelec, which is the organization. More specifically, you can see that, for example, broadband PLC devices are regulated by EN 50561 series, which are developed by the Technical Committee for Electromagnetic Compatibility, the European one, which is TC210. And then we have an narrowband range, and more specifically in the range 3 to 148.5 kilohertz, where the standard EN 50065-1, which is a harmonized standard, which is developed by SENEC TC219, so the PLC, or Mains Communicating Systems Technical Committee. And I'd like also to remind that this standard specifies that the SENEC A band is reserved for utility-driven applications. Right. So this is kind of the framework we have basically, which is based on existing European standards. So on the next slide, so here you can see that basically what we are focusing on today is this range between 150 and 500 kilohertz, where today we don't have any standard which describes how to use this band in Europe. It does not mean it's not allowed, but just one thing is that there is no standard available which facilitates the use of this band, let's say. So on the next slide, I'll try to explain why it is interesting to use the FCC band plan in Europe. So the first point, I mean, it's a pretty straightforward one, is that FCC offers higher data rates than in SENELEC bands, sorry, A and B. The FCC band in G3-PLC, it's 72 subcarriers, which are distributed between 150 and, well, 154.6 and 487.5 kilohertz, so approximately 333 kilohertz bandwidth, which offers theoretical PHY data rates, so with the highest stimulation, the APSK, of 208 kilobits per second. So that's this is even more than 4 times the expected theoretical data rate we obtain in the SENELEC A band, which basically distributes 36 carriers in a 54.7 kilohertz bandwidth. So it's purely mechanical. You have more bandwidth. Be careful, the carrier spacing is not exactly the same, so we don't have as much carriers per band in FCC than in SENELEC A, but nevertheless we have 4 times data rate, and of course even more data rate than in SENELEC B, where the band is even smaller. So that's the first straightforward argument on why it is interesting to use FCC whenever needed, right? Whenever the application use case is needing it. The second argument on the slide afterwards is about the situation in terms of electromagnetic compatibility. So next slide, please, Leon. So on this one, I'd like to really remind that the FCC band, so 150 to 500 kilohertz, is quite cleaner than the SENELEC bands. You have lower noise. Why that? Because between 9 and 150 kilohertz, there's only a limited number of EMC emission standards. CISPR 15, which actually applies to lighting equipment, is as of today, the only one that specifies emission limits. So all other devices, such as my computer's power supply or whatever, will not implement will not conform to any official or standardized emission limit. That's why also there's ongoing work in IEC between 2 EMC committees, which are 77A and CISPR H, to basically limit this non-intentional emissions, as we call it, of electrical appliances in 2 generic EMC standards, which are listed here, 61000-6-3 and -6-8. And basically, these generic emission standards will give first rules to limit these emissions in these bands, and these can also be then declined in product standard whenever, I don't know, maybe the computer industry wants to have different limits that of course should be lower than these generic standards. They can do it. At least there will be these references, right? But it's not yet the case, but work is in progress. Above 150 GHz, the situation is quite different because we have a lot of different standards which exist since a long time. We have the product standards such as CISP11, CISP15, CISP32, and also others, where you actually have a quite already strict emission limits that are in place. And this really explains what you can see on the pictures below, where when you have, for example, when you look at the picture on the left side, you can see on the below the FCC bandwidth, so on the standard 8 part, of course, you see that without load you have a certain noise floor, and as soon as you add some loads, so here, for example, you have in the middle you have the TV, the ventilator, refrigerator, and laptop. Noise is rising by a significant level, but this depends on the characteristics of your load and how they are designed, and even how nicely the power supply is designed from an EMC perspective. So here you see really that the standard A band, or the standard bands in general, are really exposing to more noise than in the FCC. So this is really the main reasons why it's interesting to go to FCC band plan to basically get rid of these inconveniences. So now on the next slide, I will talk a bit about where we stand with the FCC band standardization. So as said before, we have EN 5065-1, which is the European reference standard for narrowband PLC, but currently it is limited to the band 3 to 148.5 kHz. In addition, you have ITU-T G901, which is one standard which defines maximum output levels, which covers the different frequency bands of G3-PLC. And we also have an IEEE standard called 1901.2, which also defines maximum output level, but also some methodology as explained afterwards, which is also covering the different G3-PLC frequency band. But on the next slide, you will see that standardization is not regulation. Really be careful about that. Standards are really of voluntary application. They are not equivalent to regulation. Regulation, basically, it's something, it actually defines a set of mandatory requirements. So mandatory is quite different than voluntary, right? So regulation, you have to apply it. Standards, you may use them. And a standard could eventually be referred to by regulation as to help a manufacturer to fulfill all or part of some regulatory requirements, right? So having this in mind, on the next slide, I will then explain basically what it really means. So EN 5065-1 is harmonized by the EU directive for EMC. This means basically that the standard is referred to by the directive as it could help a manufacturer to fulfill the essential requirements, how we like to call them in Europe, to achieve EMC at the end. So the manufacturer may use EN 5065-1 requirements or prescription to derive a presumption of conformity with the essential requirements of the EMC directive, right? So that's what we have, at least in the band 3 to 148.5. Above, well, there's some preliminary work which is ongoing in the Senelec TC I chair, where we explore extensions of the existing 5065-1 standard beyond 150 GHz. Again, it's preliminary work, so at that point, it's not, there's nothing usable as standardization on that part. I talked about ITU standard, which actually defines maximum output level in the FCC band plan as well. So these limits are recommendations, which are, by the way, recognized by ITUR, which is nice. ITUR, again, is not a regulatory body. It's just, it helps regulatory bodies with worldwide regulations. At least the good thing is that they are recognized by them. They did not oppose to it. And then it's up to national bodies whether or not they recognize these limits. At least in the EU, the regulation currently does not recognize these limits, or at least these standards as a standard that can be referred to by regulation. That's the situation today. Same for IEEE 1901. These limits are not recognized by EU regulations. But again, standardization is one way of doing things. You can also use other methods, as will explain Anil. So I think the next slide should be, I hand over to Anil then. Thank you.
Yeah, thank you, Cedric. Thank you for giving me the floor. My name is Anil Mengi, and I work at the company Debulo AG from Germany. And I have been working almost 11 years. And some of you may know that Debulo is very well positioned in in-house power line applications. And this is also quite important topic for in-house power line, where about 1.6 megahertz, especially for MIMO applications, there are no harmonized standards. And I work also the last 6 years as a marketing chair of G3-PLC Alliance. And I will go through the electromagnetic compatibility aspects in Europe, and also we will look at the look at the question how we get the CE labeling for the G3-PLC devices in FCC band. So if we go to the next slide, so first of all, it's quite important to mention that the European Commission is of the belief that the same regulation principles should be applied to all telecommunication devices. So irrespective of underlying technology, so technology agnostic it should be. So consequently, PLC systems cannot exceed the radiation levels of other telecommunication technologies such as DSL. So in that case, we don't differentiate PLC technology from other telecommunication devices. So standardization and regulation under the EU, they are based on some key principles. As Cedric also mentioned, that we have a clear separation between the legislation and standardization. So if you look at the legislation, we see the main role of the European Commission through the regulations and directives. So if you look at the EMC, we have a directive 2014-35 EU, shortly EMC directive, which defines the framework of the EMC requirements. So I will touch to this directive in the next slides. And as we said, let's stay in the before one slide. We come back. The EMC directive defines the framework, and the transformation of the EMC directive into the national laws are done through the member states, member countries. So as an example, in Germany, the national law is Schutz-EV, so Sicherheitsfunkschutzverordnung, and the executive body of controlling that, monitoring that, is the Bundesnetzagentur, shortly BNetzA. These are examples from Germany, and this is the national regulatory authority. So they are also responsible for the interference complaints. So other side, we see the standardization, and standardization in the EU can, of course, trigger the market growth. Standardization has a task of defining the technical details of the implementations, and it also touches to the regulatory side. So in that case, in the standardization, we have EN 55032. Here it's written 22, but it's the new one is 32. So now we can go to the next slide. And on the next slide, as you see, there's a collaboration between the European Commission and the standardization bodies, Senelec, ETSI. And the standardization bodies, they have the task of drawing up the corresponding technical details. And these technical details, they are drafted in the related working groups, and they are circulated through the national committees of the member states, member countries. And afterwards, there's also one important step, that these standards needs to be published under the official journal of the European Union. If they are published under the official journal, they are called harmonized standards. And harmonized standards, they refer to the, let's say, presumption of conformity. So it's, I think, quite important. So presumption of conformity means that these standards are not mandatory, but they remain voluntary. Alternative paths are possible. So the manufacturers can say that they don't want to use this standard, but they need to prepare then a technical construction file. But if they refer to this standard, they don't need to prepare a technical construction file, and referring to the standard is also enough to prove that these products are comply with the essential requirements of the directives. So the next slide, Leon, please. Yeah. So in the with respect to EMC in Europe, PLC is a telecommunication network and is controlled in the EU under the framework of EMC Directive 2014/30 EU. And if you look at this directive, we see two basic protection requirements. The first is, of course, the emission. So emission means that we need to ensure that the EMC disturbance produced by the device do not affect the functioning of other devices. And then we have also the immunity. Immunity means that we need to ensure that the device has an adequate level of intrinsic immunity to enable itself to operate in the presence of the electromagnetic disturbances. So I think one of the important takeaway from Cedric was that in case of immunity, we don't have immunity standards in the frequency range below 150 kilohertz. That's why there's interferences between different electronic devices. In case of emission, however, we don't have a harmonized standard above 150 kilohertz till 500 kilohertz. So this is why this webinar is about. So let's go to the next slide. So if you look at the market access of PLC products in the EMC directive, the market access is granted if the products are compliant with the applicable regulations. So if the regulations can be EMC safety and etc. And it's important that product-specific compliance tests are required. You know it, if you're a manufacturer, you know it from different devices. You want to have a CE label, then you need to conduct product-specific compliance tests. And I think this is one of the key points in this webinar. The Directive 2014/30 EU, EMC Directive, provides two options to prove compliance for the manufacturer. Either comply with an European harmonized standard or be certified by the manufacturer according to his own specified measurement method. And if we follow the second option, we need to have a technical construction file be prepared. Then we have the CE sign, and CE sign shows that the market access is granted. Of course, I'm referring in that case the EMC aspect of the CE sign. So the manufacturer needs to go through the other aspects as well. So let's go to the next slide and look at the question.
Well, maybe Anil, before going to the next question, there was one question from somebody in the audience.
Yeah.
And that question is, for example, if you want to use power line communication in airports, which considerations should be considered?
Yeah. So of course, in that case, we need to look at the national laws. So in that case, national laws are quite important. For example, the potentially interfered radio services within the frequency spectrum 150 to 500 kilohertz, as Wolfgang is going to talk about it after my presentation, are long wave radio broadcasters or beacon frequencies of airports. So in that case, it's quite important if you want to use PLC at the airport. EMC directive refers, of course, to all telecommunication equipment, and it's transformed into the national law. So in that case, we need to look at the national law, but also we need to look at the possible interferences that can occur in the 150 to 500 kilohertz. In Germany, as an example, Schutz-e.V. doesn't consider the beacon frequencies of the airport. So it needs to be considered additionally by the manufacturer in order to avoid any kind of interference in the future. I will come back to this point in the next slides. So the next question is, how do we get the CE marking with regards to EMC in FCC band? If you look at the EMC directive, let's go to the next slide, Leon. And if you look at the EMC directive, let's look at two options that we have. The first option is we can either by compliance with the European harmonized standard. So in that case, looking to the all PLC applications, we have two possibilities here. We have 50065-1 for the frequency range Senelec. And we have also one harmonized standard for broadband PLC. For in-house PLC, this is only for the application for in-house, and SISO applications, I need to also remind that, for the frequency 108 to 30 megahertz. If we go to the second option, or by doing an EMC assessment based on procedures and methods of the manufacturer, we have a very good example from broadband PLC market. So broadband PLC sold over 250 million broadband adapters by doing so. If you buy a broadband PLC adapter for in-house PLC, the state of art is MIMO application up to 100 megahertz, and where you don't have any kind of harmonized standard for this frequency range. So it is already adapted quite successfully for in-house PLC. So for G3-PLC using FCC band, our members, they already worked quite intensively to define the measurement methods and related limits. It is in the standard IEEE 1901.2, and it defines the EMC limits 150 to 500 kilohertz. So the manufacturer, as an example, can refer to the IEEE 1901.2 standard, can follow the same setup and the same measurement procedure, and can build up its own construction file just following the steps defined in the standard. So I want to show also some details from the standard in the next slide. So as you can see, this is the table taken from the IEEE 1901.2 standard. And as you can see, there's a frequency range considering all possible excess PLC applications under 500 kilohertz. And we have here two columns defining limits during the PLC transmission and limits out of band disturbance. And in case of 150 kilohertz to 500 kilohertz, we have a distinction between class A and class B where the device is used. And we also have the limits, quasi-peak and average. This is based on the methodology, how the limits are measured. And also we have the out-of-band disturbance limits referred to the CISPR 32 to the table. So if you use this example and would like to have your EMC aspects of the CE certification based on IEEE 1901.2, then you take these tables and you conduct your measurements. The setup is also defined in that standard, and you need to take care that the device limits are below the limits written in the standard. And let's go to the next slide. Of course, it's quite important that we do a risk assessment of interference complaints. So in case of risk assessment is also quite important if you would like to roll out hundred thousands of devices. First, if an interference complaint is filed, if someone complains that his or her device is interferent with the PLC, the national regulatory authority has to assess interference complaint. So in case in German, this is Bundesnetz A, and eventually mitigate it after examination. I have to say that the interference complaint is only for the specific device where the interference occurs. So it's not for all the devices on the market, but this is only for the device. And in case that there's some frequencies that needs to be notched, this is also only for the device itself. So as developer, we do it through the software update, and we get also some very low limited number of interference complaints for our broadband power line devices for in-house. And we do case by case, and we always do a software update to notch some specific frequencies if it's needed. So in the past, in order to assess the risk of interference complaints for FCC band in G3-PLC, we did radiation measurements during our field trials at Vattenfall Hamburg, developed together with University of Essen. I want to show you the results of that in the next slide. So as you can see, we did different radiation measurements in the basement where the meter is located outside of the house with different distances. So you see on the graph, the black curve represents the radiated measurements 1 meter, and going down, the red curve is 3 meter, and then going down 5 meter, and blue is 10 meter. And background noise is also represented as the graph there. So we also put a purple curve which shows the German Schutz e.V. Well, these results they are compared by the German Schutz e.V. So the German the intention of the Schutz e.V. in Germany is to guarantee the higher protection of the relevant frequencies on national level, and it considered 3 meter radiated measurements. So if you want to consider the German Schutz e.V., we need to consider the radiation measurements of 3 meters. So it's the red curve considered with the purple curve. So as you can see that we are quite below the radiated measurement radiation levels of Schutz e.V. So in that case, we see that the probability of interferences is very, very low, and also the probability that the regulator will act in an interference case is also very low. So if you want to, of course, protect your investment, so we also recommend that you also do a risk assessment, and you talk with the national regulatory, and then you do the radiation measurements of the meters, and then follow the same methodology, and then it gives you also future-proof deployment. Okay, I stop here, and then I give the floor to Wolfgang. Leon.
Thank you very much, Enil. Good afternoon to everybody. My name is Wolfgang Lehner. I'm working for Netz Niederösterreich since 1989, and I made my first PLC field trial in Senelec A-band 1995. Please, Leon, can you go to the next slide? With also in the last 10 years, we made different PLC field trials, and especially or only in the Senelec A-band, and we see also problems which we get with the noise in this frequency band, and that the noise will increase. So we were looking how we can use the FCC band for our smart meter rollout, and so the challenge in the FCC band are the used frequencies from different radio transmitters. Most important is, or most critical, is this the non-directional radio beacon. It's a radio transmitter at a known location used in the aviation navigation ad, amateur radio, and in the mountains we have some part of the Alps, the avalanche transceiver. please, Leon, to the next slide. What we have done, we have spoken with the Supreme Civil Aviation Authority, because they are responsible for all what is combined with mobility and airplanes. There's on one side the ministry, and the second the Austria control, which is responsible for safe, reliable and efficient air traffic through Austrian airspace. The next step was to discuss the problems, what we can do or how we can get the approval. Leon, can you go please to the next slide? The main focus was to make measurement of the PLC signal and the frequency of the different radio transmitters, and to show them that the level of the signal is very low and will have no influence to their radio system. Independent of this, we get the decision that we have to notch all the frequency bands of all non-directional radio beacon in our area of Netz Niederösterreich. The second part is we have to annual verification by an independent testing institute that the frequency bands of the non-directional beacon are not used. So to show them what we have agreed, we have to show them every year. So we will not really use these frequency bands. If we have any case of disturbances, we have to follow the orders of the authority. In worst case, it could be possible so we have to switch back to this NLAG A band. But the good news, we have no any disturbances since more than 2 years where we use the FCC band. Leon, can you go please to the next slide? What we have to do, or what was our task? We have to look which non-terrestrial beacon has its range, which go to the area of Netz Niederösterreich to Lower Austria, and which subcarriers will be used from these different radio beacons. And this is not only from our country, it could be also outside from the neighbor countries, maybe from Slovakia and so on. And when you go to the next slide, Leon, you will see a map. In the middle, you see Vienna, and there are the different radio beacons from Vienna, from Linz, from Bratislava and Budapest. This means that we can only use, at the end of the day, we can only use 45 of the 72 subcarriers in the FCC band. And for Austria, most of the DSO use FCC band, and each DSO has to make his own analysis which radio beacon will be in their area, and so it's from DSO to DSO different. Please, Leon, to the next slide. This was our decision to be safe, that we have notched 7 additional subcarriers, also for the amateur radio and for the avalanche transceiver. Amateur radio on 472 kilohertz and 479 kilohertz, and the avalanche transceiver for 457 kilohertz. So in summary, we use only 38 of the 72 subcarriers in the FCC band, and especially for this solution, Vienna and Netz Niederösterreich has the best situation in Austria, because from Budapest and Bratislava we have also their signal. What we see and all our results, what we get experience with the FCC band, our biggest advantage is that we have much less interference than in the NLAG A band. And I can show you some figures from our smart meter rollout on the next slide. In the moment, we have more than 725,000 smart meters installed. It's more than 80%. We have no interference to any customer device through the PLC signal. We have no interference with any radio service. In some cases, if the power supply of a modem or a receiver made a lot of noise, in such a case, we installed filters, but for 725,000 meters, which we've installed yet, we have installed 90 filters. Our calculation was for the clean up after installation, the whole area of a substation. And our experience said we need much more less time as we thought in the beginning. And our really success rate, or the daily reading success rate, more than 99%. So we are really happy with the experience with the FCC band together with G3 to get such a high daily reading success rate. Thank you very much.
No, thank you, Wolfgang, for sharing your experience with G3-PLC and FCC, and I'm glad to see you can share these good results of your rollout in Austria with over 99% success rates. So that covers the 4 questions we mentioned in the beginning of the webinar. So we addressed all of them, and if you have any questions, then please raise them in the control panel. One question for you, Wolfgang, maybe. I think you already addressed it a little bit in your results of the rollout. There was one question about what are the typical issues that PLC communication has faced while in use, and how you addressed those in the rollout. Is there anything you can add to that?
What we see is that when a device is really working, well, we have no influence to the FCC signal. All the problems which we got was devices which was not working very well. It was or sometimes it was necessary to repair or anything else because they are very old devices. But in general, is the investment and time to be successful on the field with all the devices which are working on the same grid is very low, and only maybe it's also experience the longest distance without any repeater, where we use PLC, is more than 1 kilometer.
And there is another few questions about Austria, Wolfgang. A specific question: what kind of filters was used to reduce the power supply unit of the modems?
I will not make any advertising, but I think we use Eichhoff filters from a German vendor.
And I remember we had a separate webinar about this topic 1 or 2 years ago, and in that presentation we also included an overview of different filter types used by several DSOs. So I will add those slides to the presentations, which I will share later. So we'll share some more details about that. Another question, maybe you can answer, Wolfgang, right away. Which transmit level can be used in Austria in FCC band? Is that something you know by heart, or any of the other participants maybe?
don't know. Sorry, I cannot answer this question, but I think there's not different to other countries. Maybe Cedric?
Yeah, I would, of course, I'm not 100% sure that this is actually the figure that has been used, but to me, it's in the same order of magnitude that what is specified in ITU G901. So you have the 120 dB microvolt limit defined for 200 Hz bands over the whole frequency range. Then I think you have a global level with a higher resolution bandwidth covering the whole bandwidth of the signal, which is 137 dB microvolts. But again, it might be a little bit lower.
But I can give the answer afterwards. I will send you, Leon, and maybe you can share it.
Yeah, yeah. Another question, maybe Cedric, you can answer. How is meter reading implemented? Is there an IPv4, IPv6 stack implemented?
I mean, if we have, if the regular G3-PLC is used as defined and as certified, it is indeed run with IPv6 above 6LoWPAN. And in many countries, the metering protocol GLMS-COSIM is used. I assume it's also the same in Austria, but maybe Wolfgang can also confirm this part.
Yes, if I understand it well, Cedric, we use GLMS-COSIM
Okay.
for the protocol 100%.
Any further questions, then please put them in the box. There is another question which is about the G3-PLC hybrid technology. Well, that's a different topic, and we can spend another full webinar on the hybrid technology. And actually, we spent already quite some webinars on hybrid technology. So if you go to our website, you can find multiple presentations and webinars on the hybrid technology if you want to know more about that. And also there was a question about certification specifically for the hybrid, and also that information you can find on the website, and I will share the specific information with the people posing these questions. And a question which is in the topic of this webinar, Cedric, maybe you can help answering the next question about DC power line.
Yeah, so I see it as well. So the question was a DC power line, which is separated from public AC power line, is not limited by any regulation. Is this correct? So indeed, EMC DC networks is something that is maybe not specified for every type of installation. Talking for myself in something like TC219, so the mains communicating system committee, we know that there is some work being done for specific installations, and more specifically for photovoltaic installations, where there is a use case to use power line communication between PV panels and converters. And in that case, indeed, there's some work to be done to specify how EMC is achieved. So indeed, as far as I know, there is no further existing standard than the one we are starting to work on.
All right, thanks for answering that, Cedric. And the next question is about data rates, specifically at UDP layer. We talked about data rates recently, Cedric.
Yeah. Yeah. So of course the data rates here, I mean, for comparison purposes, is always good to have an idea of what the maximum PHY data rate which is achievable can be. So here in FCC we talk about 208 kilobits per second. So like we talk about 45 kilobits per second. Of course, if you go up in the protocol stack and up to UDP, it will be of course less. But of course, Then it will also depend a lot of the number of retries you may have, your routing topology, the number of hops, but at least what I can say in terms of measurements, I did myself 7 years ago. I was able in the 8PS case, the highest relation, so 208 kilobits per second physical data rate, I was able to go to approximately 70 kilobits per second. I mean, the order of magnitude, I think we have a user guidelines that describes this as well. And actually, we also are refining a bit the numbers to make it as readable as possible. But yes, from 208, we go back to something like 60, 70 kilobits per second PDP layer. In the Center Lake A, I would assume it's about 10 to 15 kilobits per second at UDP. Of course, this is one hop, and this can vary depending on how you use the metering. Now, the question is, with notching, I guess then the computation has to be made, and I don't have the figure in mind.
And I think part of the answer you just gave, Cedric, can be found on the website, where we included this overview of the data rates in the specific band plans, right?
Yeah. We are also in the process to refine it to give more proper information.
Yeah. A last question, looking at the time before we have to wrap up. It's a question about rollouts, so not really linked to FCC band plan, but Wolfgang, maybe you can help with that. So in rollouts, what do you do if a certain PLC meter, for example, cannot be reached?
When we don't reach a PLC meter, or it's only one meter where we have too much disturbances, we change to a point-to-point meter in such a case. But I hope this was the question. But first thing is always analyze with measurement device on field. Is the meter working? Is too much noise? Can we solve the problem with a filter or anything else, but normally filter? And if this will not help, also think we will change to a P2P meter, but in the moment we have no P2P meter installed in such a case. Mm-hmm. But yeah, this would be the last. And at the end of the day, this will not help. The customer will get no smart meter, because Austrian regulation said we have to install by 95% of our customers smart meter. So we have a range of 5%. Yes, our goal is 100%, but in this case, the regulation will help us.
Okay, but that's very rare situations which you have not encountered, I believe. And there is. We did a webinar, like I mentioned earlier, about maybe it was last year, about cleanup, where different DSOs shared their experience specifically about this topic. What kind of analysis do you do in the field? What tools can you use? What filters could be used? So if you want to read more about that, see more about that, I ask you to. I kindly refer you to one of the recordings on the G3-PLC website. If you have any further questions, please don't hesitate to contact any of us. You can see the contact details here on this slide. I want to thank all of you for attending today's session, and a special thanks to Cedric, Neil, and Wolfgang for making your presentation. So if you have any further questions, don't hesitate to contact any of us. thank you again for joining, and we hope to see you again soon in one of the other webinars we planned this year, or to meet in person at one of the conferences in Bangkok later this year, Frankfurt, or Latin America maybe. So thank you, and hope to see you again soon. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye.